Okay, we're going to do page 37, number 13. It's a review for the static equilibrium, and I've already drawn out a diagram, or at least a free body diagram-ish of it. A 588 Newton mother sits on one side of the seesaw, teeter-totter, and she's sitting a distance of 2.20 meters away from the pivot. So this is 2.20 meters away from the pivot, and I'm drawing her on the right side. Her daughter sits 2 meters from the pivot on the other side. If the force of gravity on this child is 256 newtons, so there's a girl that's 256 newtons that sits 2.00 meters away from the pivot. If she sits there, where must the mother's other child sit to balance the seesaw if the force of gravity on him is 412 newtons? So the big question here is, what is this distance here, x? The distance, let me just highlight that. That distance, boom, that distance there. That's what we want to find out. Where does that boy need to sit to balance out the seesaw, the teeter-totter? So this is a torque question, and I've drawn 3 out of the 4 forces that are being talked about and demonstrated here. I've drawn the mom force down on the right-hand side and the boy and the girl on the left-hand side. The 4th force is, can you guess? Is a force upward at the pivot. This fulcrum here, this pivot point here, is pushing up, and it's a pretty big force. The force up by the pivot point. Most people kind of ignore that when you're doing this question because you think we're just going to pivot around there. But there is that point there, and this is why we choose the pivot point for our calculations here. The pivot point is going to be there because we want the torque of this upward force to be 0, so that we don't have to worry about it. We could figure it out. It's just going to be 588 plus 412 plus 256 because the force is up has to equal the force is down. So we could figure it out, but if let's just forget about it. Let's just calculate the torques as it is. So we'll swing back over here and we'll write down the sum of the torques is equal to 0. And the torques clockwise, the torques clockwise has to equal the torques counterclockwise. And clockwise is this way around the pivot point, and counterclockwise is this way around that pivot point. So clockwise is the mom. The torque caused by the force of gravity on mom has to equal the torque caused by the girl plus the torque caused by the force of gravity of the boy. So far so good. Now the torque formula is force times distance times the sine of the angle between these two vectors. And since these are all at right angles, let me just demonstrate that little fact that they're all at right angles. There's the radial arm 2 meters out to the girl, and the girl's force is straight down. That makes a right angle. Same thing with the mom. The distance is out here and of 2.2 meters, and that is at a right angle. Mom's force is down. All the angles are 90 degrees. So I'm not going to be totally lazy. I'll just write down FD sine theta and FD sine theta of the girl plus FD sine theta of the boy. But in each of these cases, sine theta is going to be 1. So the force of gravity of mom, 588 newtons, times a distance of 2.20 meters, and this is just 1. And that has to equal the girl, which is 256 newtons. Her distance is 2 meters, and this is just 1. And let's do the boy here, plus the weight of the boy, 412 newtons, times this distance that we don't know, x. And this, of course, this sign is also 1. So let's pull up the calculator. (588 times 2.2). The torque caused by Mum is 1293.6 Newton meters. Torque caused by the girl is 512 Newton meters. And the boy we don't know yet. 412 newtons times x. Okay, so the total torque clockwise is 1,293.6 Newton meters. So I'll subtract 512 from it, and that will be the torque caused by the boy. So the total torque, let's just zoom out a tiny bit here. The total torque by the boy is 781.6 Newton meters, and his weight is 412 newtons, and we have to multiply it by that x, and you can even see why it has to be in meters now. So 781 divided by 412, x is going to be 1.897, it says. I'll put this down initially, what my calculator says. Things here are all in 3 sig figs. It screams everything is in 3 sig figs. So I'll just round this up to 3 sig figs. And that'll be 1.90 meters. That's how far away. So just in front of the girl. The girl's sitting at 2, and he must sit at 1.9. Ta-da! Don't forget to smash the like button, subscribe, and come visit often.